Okay, factored form and zero product property. If it was just this simple, get it factored. Do you remember how to factor? We've practiced it a lot. If we could just say, oh, there, it's factored, and now I can use the zero product property, which says that I can make this equal 0 and this equal 0, then this lesson could be over with super quick. Okay, but for one thing, we need practice factoring because some people are still not good at it. And number two, people just try to guess this one and they go, oh, it's 1/3. No, I mean, it's 3/2. No, I mean, it's negative 3/2. If you just try to guess what the answer for that one is, it's not going to work so well. So you got to set this little equation up. If you actually set up the equation, 99 out of 100 honors higher algebra kids can solve this equation. But if they just try to guess in their head because they think they can do it, and like, oh, I think it's 2/3. No, it's not 2/3. Okay, and it's not negative 2/3, and it's not 3/2. It's actually negative 3/2. But if you just solve this, it'd be so much easier. We could have half our problems are just of people trying to do this in their head. It's negative 3/2. And this other side is a no-brainer. A 3 would make it equal 0 in here, so the answer is 3. And I'm okay with you not showing your work on that side, on that kind, because you can do that in your head, right? All right, the lesson could be done right there if everybody was good at factoring. But then there's always some little fine points like this. If you have these roots now, I'm going to make simpler ones, x minus 3 and x plus 4. Do you get what they are on a graph? I think a lot of people do, but I think a lot of people don't. Would you sketch right now what you think this kind of looks like? If you are really understand this, you should know where the parabola is. If you don't know, then watch and I'll show you. We're trying to find its x-intercepts. These things are super important. They've got 4 names. That's how important they are. They're x-intercepts, they're roots, they're zeros, and they're called the solutions. Well, just a second ago, I said you could do this kind in your head. So the answer is 3, and the answer is negative 4. How many of you knew that? Okay, then what do you do with them? Well, you go to 3, and you put a dot right there, because those are the x-intercepts. And you go to negative 4, and you put a dot right there. But then how do you make the rest of the parabola? Well, you only have 2 choices. It's either like a cup shape, like a U shape, or it's like a mountain shape. Is there any negative in the front of this thing? No, so then it's a normal parabola that looks like this. There you go. Yes?
How would you know the y-intercept?
Good question. And this is a really powerful set of statements I'm about to make here. Wait a minute, I'm going to undo and put those back. You asked about the y-intercept. The y-intercept is where, finish that sentence, x equals 0. And the x-intercept is where y equals 0. Good. So all you got to know is that. Why is there no y in this equation? Because it would be right there. Do you get we made y equal to 0 to find the x-intercepts? All right, so then how do we find the y-intercept? We say x equal to 0. So you put a 0 here and a 0 there. Do you get that turns into negative 3 times 4, which makes negative 12. I can tell you the y-intercept of that thing. This part right here would be y equals negative 12. Apparently, it's lower than the way I kind of drew it. But I was just sketching it, so it was close enough. Okay. Next one kids got stumped on was they told them that at negative 2 and negative 4 that there were x-intercepts. And they told them that it was an upside-down parabola. How did they tell them that? By having a negative in the front of it. I want you to figure out where the vertex of this thing would be. If you sketch it and use logic, it's not hard to tell where the vertex is. sketch the parabola around this. Figure out where would the vertex have to be. Something, comma, something. I know somebody's already got it, but I have a question or an answer? Question, go ahead.
Why is it x by 4x plus 4?
Oh, I screwed up one. Thank you. That's supposed to be a plus right there. There we go. Thank you. Good catch. I'm going to pause for a minute while I give that a try. Okay. Now, I said you could use logic to figure out where that point was. Do you get, if this has a negative in front, then this thing must be upside down like this. So you get it's kind of somewhere around here. Wouldn't it have to go exactly down the middle? Remember that x-axis thing? It's called the Axis of Symmetry, and somebody said, like the Axis of Symmetry. It's an x equals number that runs down right down the middle. And that would be at what? -3. You get how that's logical? If this is -2 and this is -4, then that must be a -3. Do you get now that the vertex has to be on that line, and therefore the vertex has to be at -3, comma something? Now, I can tell just by looking at it that it's probably -3, comma 1. But let me show you how you can be sure. If you know x is -3 and you want to know what y is, you put it in here and you see what you get. You get negative on the outside of -1 times 1 equals 0. And in this case, we've made it back into y because we want to find the x-intercept. So we said, or sorry, we want to find the y-intercept. No, we don't. We want to find the vertex, so we need y instead of 0. You only set y equal to 0 when you're trying to find the x-intercepts. Okay, and then this -1 makes it 1, and so 1 equals y, and therefore y equals 1, and therefore that's a 1. All right, I need to see if you really caught that. One more that's kind of like that, and it'll go quicker. Say it looks like this. Let's say this is at 2, and this is at 6. Then what's the equation, first of all? X minus 2 and x minus 6. And then, because it's upside down, there's got to be a negative. And then use logic to figure out what this point has to be. I'm going to pause for a second and have you figure that out. One hint. It has to be right exactly between 2 and 6. So, logically, it has to go right down the middle here. And that's exactly between 2 and 6. In case you don't want to reason that out, you can actually average 2 and 6. You know what the average of 2 and 6 is? 4. All right. So that's at 4. So that means this point must be at 4 comma something. And then how do you figure out that other part? You can either use logic and try to piece it together, or you can just stick a 4 in here and here and see what you get. And it's negative on the outside, 2, -2, multiplies out to 4. That's at 4 comma 4. Raise your hand if you knew that. Awesome. Okay, that's how you find the vertex without even being told where it is. You figure out that it's exactly between the two roots. All right? One more, and this should take you 1 minute. Ready? Let's say that it's like this, and that's at 2 and that's at 4. What's the vertex if it looked like this? And oh wait, I'm not going to make it negative. What's the vertex if it looked like this? Use logic. Okay, sorry about that. This should have been a minus on that 4 right there. That should have been an x minus 4. I apologize. That will fix it so that it can work now. Sorry about that. I know the parabola has to have its center or its vertex, somewhere there. This dot here must be 3 comma something. I'm going to put a 3 into here to figure out exactly what it is. Raise your hand if you had that one right. Okay, awesome. What if I give you this and ask you what the roots are?
We don't have any coins for 1 and 4.
At least you knew what roots were. I know, it's read the teacher's mind, but at least you knew where the roots were. I never used the word roots earlier this hour, did I? But you knew right away to change that to what? X-intercepts. The roots are the same as the x-intercepts. Okay, what if I asked for the zeros? Same thing. Roots, intercepts, x zeros. How about the solutions of that graph? Same thing. There's 4 names for these spots. Only one name for that, kind of. It's called the vertex. But what if it's, no, that spot is called the vertex, and that's just that if it's this way versus this way, there's 2 different things. That's called a maximum, that's called a minimum. All right, good. Next thing. What if I don't tell you what it looks like? I have no idea what that looks like. But I can at least generally say it's a parabola that is what? You should know one more thing. Yes? I like that. That's true, but that's not what I was going for. It's a parabola that's got what? What do you think?
I was going to say it's been moved down 8.
And it's not been moved down 8, but it's got -8 is a thing. It's just that it's not that it's been moved down 8. What is that -8?
The Y.
It's the y-intercept, because that's if I put in x equals 0 to see how these disappear. Okay, so I know some stuff. I know that it goes through -8. That's all I know so far. Tell me something else about my parabola. Even on a really complicated looking one, you could know one more thing. Yes? The only problem is I don't know if it's this way or if it's this way.
It's that way.
How do you know it's that way? Yes, you're just guessing. Yes, there is a 50-50 chance you're right. So what if your life depended on that 50-50? You've been abducted by a math terrorist, and you are in. Yeah, there's such a thing as weapons of math destruction. No, mass destruction. Sorry. Anyway, all right. Would you, if your life depended on it, how can you tell? Yes?
Because of the positive 5.
Mm-mm.
You have to multiply it out. That's how they do it.
Kind of. What does he mean when he says multiply it out? Or maybe he doesn't even know what he means. But oh, if you could factor it, that'd be awesome. But you can't factor it because it won't factor. So how could you do it? Okay, and it always takes every class forever to finally get to the thing that I told you would work on every single factor or graphing problem you ever had for the rest of your life. You can make a table, an XY chart. You could know for sure what it looks like from that. Now, I don't need you to do that every time. It's only on the stumpers. Because if it would have factored, that'd have been genius. Because as soon as you get it factored, do you get how powerful it is to know, oh, I know where it touches. I know its roots. It's at 5 and -1. I know it touches here and here. I know it's right side up because it's not negative, so I know it. You can graph these really quick if they're factored. All right. So do you get how factored form is really pretty nice because you can right away know where it touches. Then from that, you can logically figure out where the vertex has to be. So all kinds of good things about knowing factored form. But just don't forget about vertex form, because there's a question or two on your homework like this. Don't forget vertex form. That is not the roots. That's telling you the vertex. What's the vertex? 3, 2. Why not negative 3, 2? Don't trust the inside. Inside's the opposite of what you think. Okay, good. And is this one right side up or upside down? Well, it's a normal one. It hasn't been flipped. So what's normal? It's a U shape. It's a U shape that touches it, not touches, it goes through 3, 2. And that's the vertex. So it must be kind of like that. All right. So vertex form is really good for graphing. This form, really good for graphing. This form, really bad for graphing. The only thing I know is it's what? Y-intercept. But if I could factor it, which I can in this case, then you'd be able to graph it. Do it. JH, tell me what you factored it to. X plus 1 and minus 6. Let me double check you just to make sure. The first make x squared. The outside and inside is where all the action happens. Because if those two together make this, you pretty much got it. And they make, oh.
Switch to positive and negative.
Ah. Now, this is a good learning opportunity though. It's okay. It's okay. So you thought you had it, but it was actually going to give you negative 5x. Do you get what to do then? Switch the signs. This should become plus, and that should become minus. Now, I'm glad I double-checked it, and that's what you should do too. Factoring is something you can be sure if you're right on. You don't just guess, well, I think that's it. Multiply it out. See if it worked. Okay, now that's it. So now that I got that, I can tell you that the roots are negative 6, because that makes this part 0, and positive 1. Negative 6, positive 1. Oops, I didn't need such a long hash mark there. Ah. So there. I go through this point and this point. Is it a U shape? Yep, there's no negative in front. So it's a U shape. And if I needed to know this, I could get it, but it's going to be icky because it's going to be at 3.5. Negative 3.5. Now, could you find it? Yeah, you just have to stick in negative 3.5 here and here. And it's a little icky, but you could do it. And you could find the vertex if you had to. We wouldn't do one that hard. At least not until you're good at this. How did I get negative 3.5? Remember, you can average them. You can average 1 and negative 6. If you average them, you add those together, it makes negative 5. You divide it by 2. Oh, wait a minute. That's negative 2.5. I'm glad I checked myself. Some rap lyrics that actually make sense. Check yourself before you wreck yourself. I think that was Ice-T, but anyway. Okay, so your homework for tonight. It is a Schoology quiz. I'm going to open it with you. Together, we can start this thing. Okay, so find the little Schoology quiz. Looks like the puzzle piece. There we go. What are the zeros? Oh, no, what are zeros again? Oh, they're the same as roots. They're the same as x-intercepts. There's those spots that touch the x-axis. What makes this part 0? That's really easy. Negative 7. What makes this part 0? 0. And if you have to, set it equal to 0. If you're stuck on something like this, go, I want 4x to equal 0. And then x would have to equal 0. And here's the other one. X would have to equal negative 7. Now, this is an important point. Do I write it like that? Yes. In this case, these are your two answers, and that's what you write. And now there you got the first one right. Okay, but do you get why a kid in first hour asked me, couldn't I write it like this and this? That's where those points are too, right? Those are called ordered pairs. If they ever ask you for an ordered pair, that's what they're asking you for. is something comma something, okay? They're the same spots, just a different way to say it. -7 could be thought of as right there, as just x is -7, or you could think of it as -7 comma 0. Okay, so only if they ask for ordered pairs do you have to make them into points. All right, for this next one, I strongly recommend making a little sketch of it. You know from looking at a sketch what these things look like, and that'll work out the best. This is true on the ACT test also. We're very visual beings. You show us a picture, we can get the situation down like right away. We get it. You might have to write a whole paragraph, or even, well, the old saying is a picture is worth 1,000 words. If you can make the little graph for number 2, I think it'll help you a lot to find x-intercepts and its vertex. All right. And remember, when it asks for ordered pairs, that's when you need to make them a point with a parentheses and a comma. All right, I think that sums it up pretty well. And if you need more help now, I'll be glad to help you one-on-one. Just come on up and ask.